Hello and welcome back everyone. In this lecture we will learn a fundamental data type called integer. We have a variety of data type to study and today we begin our session with integer data type. An integer is a positive, negative or zero valued number, or you can say integer value that we study in math. So the int data type is used to store numeric value with no fractional part. Recall from the previous lecture, that is introduction to data type, integer can take either 2 bytes of memory or 4 bytes of memory depending upon the machine you are working with. Because 1 byte was 8 bits, therefore 2 bytes equal to 16 bits and 4 byte equals to 32 bits. More the size, more content it can hold. If you want to know the size of your machine's integer data type with the help of C program, then you can use the size of operator to do so. Size of is a unary operator, not a function. It may appear to be a function, but it is not. The size of operator determines the size of any data type that we provide to it, according to the system you are working on. This is the same code as before. Let's run it and see how big the integer data type in my system. As you can see here on my computer, the size of integer data type is 4 bytes. Maybe in your computer it is 2 bytes. It totally depends on the system. If the size of integer data type is 2 bytes in your system, don't worry about that. Now let's define the range. Range is simply means upper and lower limits of a set of data. For example, here you can see this set considered some value 0, 1, 2 up to 5. If you determine the range of a set of data, then you have to determine the minimum value as well as the maximum value. And in our case, the minimum value is 0 and the maximum value is this set of data is 5. Therefore, the range of this set of data is from 0 to 5, you can say. You can see in this set of data there is no value which is less than 0 and also there is no value which is greater than 5. If you take another example, the range of 4 digits of decimal number is from 0 to 9 that we use in our day-to-day life. We have to know its minimum as well as the maximum value for 4 digits of decimal number. Minimum value is 0 when all digits are 0 and the maximum value is 9999 when all digits are 9. You can get the answer by multiplying the weight of the value. If I multiply this 0 with 10 raised to power 0, that is equal to 0, 0 with 10 raised to power 1, that is equal to 0, plus 0 with 10 raised to power 2, that is equal to 0, plus 0 with 10 raised to power 3, that is equal to 0. Finally, we got an answer 0. For the maximum value, 9 into 10 raised to power 0, that is equal to 9, plus 9 into 10 raised to power 1, that is equal to 90, plus 9 into 10 raised to power 2, that is 900, plus 9 into 10 raised to power 3, that is 9000. And finally we got 9999. And if we try to add 9999 plus 1, then this is a 5-digit number, not 4. So the maximum value is 9999 for 4 digits of decimal number and the minimum value is 0 when all digits are 0. So finally the range of 4 digits of decimal number is 0 to 9999 and the same here with the 4 bits data. Note, bit means binary, means base 2. Just like base of decimal number is 10 and in decimal numbers we have 10 different digits from 0 to 9. Similarly, base of binary number system is 2. It means in binary number we have 2 different digits, that is from 0 to 1. In the binary number system we have only 2 digits 0 and 1. Now let's see here. The range of 4 bits data is from 0 to 15. Means minimum value is when all bits are 0 and the maximum value is when all bits are 1. For maximum value, first of all, the base or radix of binary number system is 2. Just like before, the base of decimal number system is 10, we multiply 10 raised to power the weight. In the same way, in binary number system, we multiply 2 raised to power weight. For maximum value, 1 into 2 raised to power 3 plus 1 into 2 raised to power 2 plus 1 into 2 raised to the power 1 plus 1 into 2 raised to power 0. 8 plus 4 plus 2 plus 1, that is equal to 15. So the range of 4 bits of data is from 0 to 15. Here we have 4 bits of data, so calculating them is easy for us. But what if we have large bits of data? So for that we have a formula, that is 2 raised to power n minus 1. Suppose you have a 64-bit data, then calculating this is very difficult. Then this formula is quite handy to apply. Here by replacing with n equal to 4 for 4 bits data, you get 2 raised to power 4 minus 1, which is nothing but 16 minus 1, that is 15. If in your machine the size of integer is 2 bytes, then the unsigned range is from 0 to 65535. By applying the same formula for calculating the maximum value, by replacing n with 16, you get 2 raised to power 16 minus 1, which is nothing but 65535. Usually you have to represent the negative value as well, and that we do with the help of 2's complement representation. We actually have 3 different representations to represent negative numbers, and they are signed magnitude, 1's complement and 2's complement. But most of the computer 2's complement is used. 2's complement is range from minus 2 raised to power n minus 1 to plus 2 raised to power n minus 1 minus 1. Here you can see minus 2 raised to power n minus 1 by replacing with 16, we get minus 2 raised to power 15, which is minus 32768, and plus 2 raised to power 15 minus 1, which gives us 32767. On the other hand, if your PC supports 4-byte integer, then the unsigned range is from 0 to 4294967295 by applying the same formula for maximum value. Signed range can be obtained by using the 2's complement representation. Minus 2147483648 2 plus 2147483647 by applying the same formula. Now let's talk about modifiers such as long, short, signed and unsigned, and some programming examples. First of all, what modifiers is? Modifiers are keywords that change the meaning of a basic data type like integer, float, character. Modifiers are prefix. A prefix is a letter or a group of letters that we add to the beginning of a word. Prefix change the meaning of a word. For example, here we have a word unhappy. Here un is a prefix that change the actual meaning of this word. Simply in C programming language we have prefix that change the meaning, or you can say the size or sign of any basic data type. Long and short. These are modifiers used to make it possible for a data type to take either less or more memory. Suppose if the size of integer is 4 bytes in your computer, then using short in front of integer to make it 2 bytes. For example, on my computer the size of short integer is 2 bytes. On the other hand, the size of long integer is 8 bytes. If you remember, in my computer the size of integer is 4 bytes, and after adding a prefix that is long and short in front of integer data type, the size of integer is now changed. Note, it is not compulsory short take less memory than the integer and long take more memory than the integer. The only thing which is guaranteed is that size of short is less than or equal to the size of integer and less than equal to the size of long. If in your machine the size of long integer is 4 bytes, then long int make it 8 bytes. It should be noted that if in your machine the size of long integer is 8 bytes, then the long integer is not 16 bytes. That is why the long int is 8 bytes only, or you can say the maximum space to be allocated to a long integer is 8 bytes. As I already told you, integers can have signed and unsigned range. Typically, signed range is from minus 32768 to plus 32767, and the unsigned range is from 0 to 65535 for 2 bytes integer, and for 4 bytes it would be the range. For representing the negative value in a computer, you have different representation, and one of the widely used representation is 2's complement representation. Note, Range of negative numbers comes from this representation only. When we declare an integer data type variable, then it is by default is a signed integer variable. By putting an unsigned modifier in front of it, allow us to only positive value to be assigned to it. Now let's take a look at some examples. First of all, I have included a new header file, limit.h. This header file contains of some symbolic constant that are used to determine the minimum as well as the maximum value of any data type according to the system. In this example, I have a symbolic constant int min and assigning it to var1. The symbolic constant gives us the minimum value of assigned integer according to the system, and the similar int max is assigned to the var2, and this will give the maximum value of assigned integer. Here in this example, we are trying to print the range of signed integer or signed int. Both are one of the same thing. As I already told you, by default int is a signed integer. In my system, the size of integer is 4 bytes. Therefore, the range of signed integer is from -2147483648 to +2147483647. In the second example, we are trying to print the range of unsigned integer. Here, the symbolic constant for maximum value is unsigned integer uint max. On the other hand, there is no symbolic constant available in limit header file for minimum value of unsigned integer because the minimum value is fixed for all systems and that is 0. And note down one thing here, we use %u instead of %d. %d is used to print decimal value and %u is used to print unsigned decimal value. Now let's save and run this code and see the maximum value of unsigned integer in my system. As you can see, this is the range of unsigned integer in my system. This is where I will end this lecture. This lecture is already far too lengthy. Okay friends, that is for now.